Measuring correlation. Look at this nice long-winded word. The Pearson product moment correlation coefficient. Whew. Also known as the R value. Is used to describe the strength of a correlation. So here we have a scatter plot. It is measuring the calories consumed, the weight gained. Oh, another March 15th example. And so in this one, we've got our line of best fit from our regression model from our calculator, but our calculator can also tell us an R value and R squared value, and this one comes up at 0.94. The closer that R value is to 1, the closer it is to a perfect correlation. So if you got an R value of 1, that means all of the dots line up perfectly on the line, and it's a perfect line of best fit. Obviously, when you look at the dots, they don't all line up on this line, but they're pretty close. So we get an R value close to 1. The closer it is to 1, the stronger the correlation. So an R value is between -1 and 1. 0 represents no correlation or 0 correlation. The closer your R value is to 1, tells you that it's strong and positive. The closer it is to -1, tells you that it's strong and negative. And so on the calculator, sometimes they give you an R squared value. The R squared value doesn't worry about negative or positive correlation. It just is going to tell you about correlation in general. The closer an R squared value is to 1, the stronger the correlation is in general. Oh, I can go back. So quick, I know. Here we go. Not a problem. So here we have some examples. And a line of best fit was created and the correlation coefficient calculated. And we had different values. So a -0.9, this would be a strong negative correlation. -0.5, not really strong, but still is more negative than it would be positive, looking at those dots. So we would just say it has a moderate correlation. The ones that are all 0, those ones have no correlation. And as you can see, as that number gets higher, the closer it becomes to a perfect line. So we can sort of generalize the data between 0 and 0.25. And notice I have absolute values there. So that's whether it's positive or negative. That's a very weak correlation. And then if it's between 0.75 and 1, well, that's quite strong. So how do we calculate the correlation coefficient? Well, there's some nice nasty formulas. Or we can just get our calculator to do it for us. Yes. But we've seen some of these SXY, SX, SY formulas before. And it's important that if you were given the formula, you could work with them. So to know what this is, a sum of x times y, a sum of x squared, a sum of x all squared. And we had used some of these values already when we were figuring out the slope of our regression line. So we'll do one by hand. Do you still have these values in your calculator? The 0.1321 and 35? So all the calculations are there. Again, we've got all the sums. We created a chart of all those values. And it comes up with a correlation coefficient of 0.5. Not very strong as far as correlation. I'm going to check if I still have the values in my stat here. Yeah, 1, 3, 2, 1, and 3, 5. So if we remember from before, I'm going to clear out these. Zoom 9. Those were our dots. As a memory, we can go to stat, calculate our linear regression, number 4. List 1, list 2, no frequency. We can store it. Oops. Stat, calculate, number 4. We can store our equation into y1 and calculate. Another thing I had done before is I had changed my window so that I went into the negatives. Just allowed me to see my axes. So there's our equation of our line of best fit. And what we're going to want to do is figure out the correlation. Obviously, it looks like it's positive, but having just 3 points that do not look at all like they form a line, right? If I take that line away, here's something on your calculator. Did you know that if you go to the equal sign on your calculator and push enter, it turns the equal sign off? And now when I graph it, it took the line away without having to delete it. Those do not look like they form a nice straight line, all 3 of them. So we can see why the correlation wouldn't be super strong. I can go back to y equals, go to my equal sign and push enter. This is apparently the best line of best fit. So we want to see what the correlation coefficient is. How do we use our calculator to do that? Well, we're going to go to our catalog, which is above your 0 button. So hit catalog. And in catalog, it tells you every single command this calculator has. What we want to do is turn our diagnostics on. When you go to your catalog, diagnostic is under D. You can hit the letter D just to get to the D's quicker. And then scroll until you get to diagnostic. Diagnostic on. Push enter and it will say done. Wonderful. What it does, now that it's turned on, is if we go back to what we did before, which was stat, calculate, number 4, linear regression. Now when I go to calculate it, not only does it find my equation, but underneath it has r squared and r. Yes? So you have to push the letter D to get to diagnostics. D, and then keep going down until it says diagnostic on. Mm-hmm. So because this would take a lot of time to do all of this data, these questions are almost always calculator questions where you get your diagnostic, where you get your correlation coefficient from your calculator. So here's one for you to try. Put those values, your math marks into list 1, your physics marks into list 2. get the regression equation and the R value, and then we'll talk about that. Okay. So what does this R value tell us? Strong correlation and strong positive or negative? Positive, okay? It would be kind of scary if as your math mark went up, your physics mark went down. That would be a little scary. These are two classes that tend to be closer together. We'll often see that as you do higher in one class, you do higher in the other, but some courses don't necessarily translate, right? If we took everybody's math mark in grade 12 and then say, now we're going to give you a mark for the clarinet. How many people play the clarinet? All right. So there'd be one person who does really well on the clarinet exam, and the rest of you would probably suck. So that maybe wouldn't be a good one to have a good correlation for. But in this case, there seems to be a strong correlation between your math mark and your physics mark. So that's commenting on the strength of correlation. Then use the equation for physics marks to find the physics mark for a student who scores 50% in math. So what would we do? We would plug in 0.849, 0.5 plus 11.3. Plug that in, and what do you get? .538. So that person is looking at having a 53.8% mark in physics.